All right, welcome to worksheet 5.1. This is the first section out of chapter 5, polynomial functions. So what makes a polynomial function? A polynomial function has a whole bunch of terms here, and we'll go over all the names of them here in a second. So it's just whole numbers for exponents. So the exponents can be negative numbers, the exponents can be fractions or decimals or anything like that. So we started out graphing like x to the first power, x to the second power as parabolas, and then we typed in the calculator x to the third power, x to the fourth power. You can go up to the fifth power. So this is a polynomial. It's just a bunch of x's. They're all separated by addition and subtraction signs, and the exponents are whole numbers. That's very important. The exponents are whole numbers. So you can classify a polynomial, which means many terms, two ways: by the number of terms and the highest power. So here's how we do it with the names for the number of terms. So this is one term is a monomial, two terms is a binomial, three terms is a trinomial, and a bunch of terms that we don't have names for that, so it's polynomial. So they're all polynomials. Even this one here is a polynomial. So 2x is a monomial. If you add 3 to it or added something else to it, it's two terms. That's a binomial, trinomial, and then we just call this one a polynomial. This right here is the names for the different terms. So if the highest power is just some number, then we call that a constant polynomial. If it has an x power, we would call it linear. So the highest power gives it the name. So this would be a linear polynomial, and that would be the constant term. If the highest power is squared, we call it a quadratic polynomial, and this would be the linear and the constant terms. If the highest power is the third power, then we call it cubic, and it's a cubic polynomial. And so this would be a cubic polynomial, and then these would be the different names of the terms. If the highest power is 4, it's quartic, and so it's quartic, and the highest power is 4. And then this would be the cubic, the quadratic, the linear, and the constant term. If the highest power is 5, then we call it a quintic polynomial. So this would be called a quintic polynomial. This would be the quartic, the cubic, the quadratic, the linear, and the constant terms. So I put them this way so you could see them, but it's quintic, like quintuplets, quartic, like quarter, like 4, a cubic, like a 3-dimension, like a cube, quadratic, so it's squared, so square is like a quad, so quadratic, linear, constant. So these are the names of the term. This is also found in the book, and everybody has a book at home. I've given you one. It's 5.1. There's a nice chart in the book that has all of this in there too, but this is me highlighting it in a worksheet. So now we're going to practice naming these. So there's 6 problems here. If you are at home and you do not have access to this worksheet or printing this worksheet off, then what you need to do is you need to write this problem down, these problems down, and then you're going to name it with these things here. And everybody has a book, so these are all in the book. Okay? So all these things are named in the book as well in section 5.2. So this first one here has 2 terms. So it's 2 terms. We call that a binomial. So but we name it with this thing first. Okay. So the highest power is 1. So we call it a linear binomial. Okay. So it's a linear binomial. And then this is just one term, right? So it's just one term, so it's a monomial in third power. So it's a cubic monomial. Okay, so try these. So here's the problems. If you want to pause the screen and write all these down. So you give it this name first, right? So this is first. And then the number of terms is second. So you write one of these words down first, and it's all based on the highest power. So you don't name this quadratic, right? It's based on the highest power, the 5th power. And so it's the highest power gives it the name. Okay? So notice we don't mention anything about constant there. It's linear, right? So the highest power gives it the name. So this 7x doesn't give it the name, the highest power gives it the name, and then just the number of terms. Okay, next page is the leading term. The highest power determines the end behavior of the polynomial. So how the polynomial curves around. So if it's positive and even, so if the highest power is even and it's positive in the front, then the left side is going up and the right side is going up. This is the end behavior of the function. If the if it's negative and even, like this would be an upside down parabola because it's negative even, followed by a bunch of terms, but it's all based on the highest power. The highest power creates the end behavior. So this would be down on the left and down on the right. So it's negative and even. All right. Then the next case is where the highest power is odd and it's even in the front. So it's going to be down on the left and up on the right. And we've seen that where it does these kind of curvy things when we graphed them the other day. So it's down on the left and up on the right when it's positive and odd. Now, if it's negative and odd, it flips it upside down. It flips it over. So then it'd be up on the left and down on the right. So this is, I went to great lengths to create this, so good job, Mr. Jackie. So now we're going to describe the end behavior on these 6 functions here. So here's the 6 functions. If you want to pause it and write these down, there's all 6 problems. Okay, so here we go. So this one is negative and odd, negative and odd. So negative and odd, right, is this one. So it's negative. We don't care about any of this. It's this here. The highest power creates the end behavior. The highest power always has control over the rest of the function. So negative and odd means it's up on the left and down on the right. So it's up on left, down on right. Okay, so I even have a little polynomial dance that I can do. So I'll put this on me. I got to get rid of this window behind me. It's so windowy. Okay, so we'll go here so it's not as much. All right. Positive and even, positive and even, negative and even, negative and even, positive and odd, positive and odd, negative and odd, negative and odd. Do the polynomial, do the polynomial. Yeah! All right, so that was pretty fantastic. So that's the polynomial dance. So then we have so this one right here, right? So 9. 9 is an even number, right? So it's even, or no, excuse me, 9 is a positive number, so it's positive and even, positive and even. So positive and even, it's up on each side. So it's up on the left and up on the right. Okay, so it's up on each side because it's positive and even, positive and even, negative and odd. Okay, so the last thing we're going to do is we're going to talk about intervals of increase and decrease. So intervals of increase and decrease, there's 4 problems here, and I'll line them up like this so you can write down the 4 problems. So if you're at home, you're going to want to type these into GeoGebra, and because you don't have a graphing calculator, or you could download a graphing calculator onto your smartphone. There's lots of them out there that you can do, and you can type these in and see them on your smartphone. But GeoGebra also works really well. So here's the 4 problems. Pause it if you need to write these down. Okay, so here's what we do. We type this in. So I'm going to type this into the calculator. I'm going to do it off the calculator here. And let's see, get in here a little closer. We're going to round everything to 2 decimal places. So this is the intervals of increase and decrease. This is not the end behavior of how it's going up and down, right? It's the intervals of increase and decrease. So I'm going to graph it here, and this one is positive and odd, so we know that it's going to be up on the right and down on the left. It's going to do a curvy thing, and that's from our little song that we just did. So we go to 3x to the 3rd power, push myself through, minus x minus 3, enter. And then we're going to have boom, 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 beep, 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 and graph. I'm going to do zoom and 6. Okay, there it is. Now, we have to find these max and mins right there. So I'm going to zoom in a little bit to make it easier on myself. I'm going to hit the zoom button, and I'm going to zoom in on that spot right there. So you can kind of see the max and mins a little better. There we go. So it's increasing, and then it decreases a little bit, and then increases. So I need to find the relative max and min. So I go to second, calculate. And on GeoGebra, you can just click on it and it shows it to you. Max. So I'm going to go over here. And I just want the x values, just the x values. Okay. So the x value is, it looks like 1/3. So I'll say negative 0.33. So just pull the x value off of here. So I'm going to make a number line. And I'm going to say negative 0.33, and I'm going to write max above it, okay, because that's the x coordinate of where that happens. Then over here, I'm going to write down the min, find the min. So we got to find the max and the min. So we go to second, calculate, and min. I want min. Second, calculate, min. So I go over here, boom, and boom. And then I go back, boom. Okay, so this is, looks like positive 1/3. So I'll put in 0.33, 0.33, and this is a min. Okay, so what's happening here is we're on a roller coaster, right? So we're going to go on the roller coaster. Roller coaster only goes from left to right. So we go like this. So we go up, 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 up. So this is positive, 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 positive. It's going up. It's increasing, right? And then what happens between those 2 points? Down. So decrease, 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 decrease. Oops. Then what happens after that? It goes up. So it's increase, 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 increase. All right. So now we have it. We know that it's increasing on these 2 intervals and decreasing on this interval in between. All right, so here's how we write this. Increase. Increase is x is greater than 0.33. X is less than negative 0.33. All right, so it's decreasing, or excuse me, increasing on the outsides. And then in the middle, it's decreasing. So we write decrease. And how we do that is a compound inequality. We say x is less than 0.33, and at the same time, x, we read it this way, x is greater than negative 0.33. So that's how we say in between in math, is we look at it this way and go, x is less than 0.33, and then we turn it around and we say x is greater than negative 0.33. So see, x is trapped, right? Like Jaws, trapped between the 2 numbers. So this is where it's increasing and decreasing. All right. So this is, if you want to type this into GeoGebra, you can just click on it and you can see the, and I'll do that real quick and show you what it looks like. I'll type this one in. And it also follows what we just did, positive and odd. See, it's down on the left, up on the right. And that was the previous page. But I want to know intervals of increase and decrease. So it's increasing, high point, decreasing, low point, high point. So that's how you write that out. But my suggestion is find the maxes and mins, because that's where it's going to switch from going up to going down, and use the calculator to do that. So I'm going to pause this and type this into GeoGebra real quick. So yeah, that won't work because it's on the screen. I have to do it differently with recording it differently. But basically what GeoGebra did, you just go to GeoGebra and you type this in using the caret key and everything, and then you just hit enter, and it gives you the picture, right? And it automatically puts the dots on there. It puts on the dot for the high point, the intercept, and the low point. It just automatically puts those dots there. And then you can just click on them and see what the numbers are. And again, you're picking out the X value. You want the X value. So increase and decrease, intervals of increase and decrease is all about stating the X values. All right, so you're going to give the rest of them a try, and that's it.